Hello, today's lecture we are going to focus on the eccentric connection with load perpendicular to the plane of riveted joint. In last lecture we have focused our discussion on riveted joint with the load acting on the plane of riveted joint. Here we will see if the load is perpendicular to the plane of joint, how it behaves. In last lecture we have discussed in details and we have shown how to design a riveted joint with eccentric load when this load is acting on the plane of the riveted joint. In last class we have shown little bit about the analysis of this type of joint. Today we will show more details and other type of joint also, means whether if rivet is hot driven or rivet is cold driven. In both the cases how design will be affected, how the analysis will be going to do. So, all these things we will discuss in details. Now, for design of eccentric connection when the loads are not lying in the plane of rivets, we have seen earlier also that we can assume this formula that n is equal to root over 6 m by MPR, where m is the moment due to the eccentric load and r is the rivet value and p is the pitch and m is the number of column in which rivets are placed. Suppose rivets are placed like this. So, in this case m will be say 3, because 1 line, 2 line and 3 line. So, rivets will be so m will become 3. So, in this way we can find out the approximate number of rivets to start with the design. So, with the assumptions of this many rivets we will start design, we will find out the stresses in different way, that means sigma Tf calculated and tau Vf calculated. Then we will see from both the cases whether it is becoming less than the allowable or not. Similarly, if the load not lying in the plane of rivets and without initial tension, that means if it is cold rivet, then the number is going to reduce little bit, because the strength of the rivet will be acting in such a way that the joint as a whole will be more stronger. So, if it is cold rivet, then we can reduce little bit number of rivets. So, we can multiply 0.8, say percentage of reduction 20% we are going to reduce. Now, we will see, before going to start the analysis, we will see that as I have told earlier also that the neutral axis we are assuming that it is will be the, if the total depth of the joint is h, the section is h, then h by 7. The neutral axis is assumed to be at h by 7. This assumption has been made by US code and as well as our Indian code is also following this assumption that at h by 7 this neutral axis will move. So, if we consider the neutral axis here, then accordingly we can find out what will be the stresses developing in different places and what will be the stresses developing below the neutral axis, and above the neutral axis generally stress will develop positive, that means tensile stress will develop, and below the neutral axis the compressive stress will develop. So, we have to make equal of total compressive force is equal to total tensile force. So, from these two equilibrium equation we can find out the neutral axis depth properly and we can find out other details. Another way of calculation is that, which proposed by the British code, is that neutral axis passes through the bottommost rivet. That means, they are considering that neutral axis is passing through bottommost of the rivet. So, if we consider that like this, then the other details can be calculated accordingly. So, there are two type of analysis, two codes have been suggested. We are going to focus only on this, that US code whatever it is proposed, we are going to follow this. Now, if we see, if rivets are like this, it is placed, so suppose like this. Now, say tensile force, this is the say h by 7 and this is suppose h. So, tensile force, it is assumption is that the tensile force is varying with the distance of y. That means, if y is this distance, say in this rivet, if y is this distance, then tensile force in this rivet will be proportional to y, T varies y. That means, I can write T is equal to K into y, where y is the distance from neutral axis to the rivet and K is the proportional constant. So, K I can find out from this. For a particular T value, whatever tensile force is developed, and the y, the distance from neutral axis to the rivet, if we have, then I can find out the value of K. Now, the moment of resistance due to this tensile force can be written as M is equal to T into y. So, this will become K into y square. So, in this way I can find out the moment of resistance. Now, for a particular rivet, I am getting the moment of resistance as K into y square. So, total moment of resistance will become, if I write MT, total moment of resistance, then it will become K into y square, because this is Ky square, this is Ky square, this is Ky square, this is Ky square, like this it will go on. So, summation of Ky square, where I means it will vary from number of rivets, means from I is equal to 1 to n, where n is the number of rivets. So, in this way I can find out MT is equal to Ky square. That means, MT I can write in place of K, I can write again T by y. So, MT is equal to T by y into summation y square. So, means theoretically I can write the tensile force in this way, tensile force T will become MT into y by summation y square. So, tensile force can be calculated from this. Now, total tensile force I can write that this is a tensile force for a particular rivet. So, total tensile force, this also can be calculated. Total tensile force, say total tensile force may be summation of T. So, this will become MT into y by y square, where MT is the total moment. So, I can write total tensile force is equal to MT into summation y by summation y square, right. So, this is the total tensile force. Now, for equilibrium equation, we can write total tensile force is equal to total compression force. That means, total tensile force will be equal to total compressive force. So, with this equilibrium equation, we can write that total compressive force will become nothing but same, that is MT into summation y by summation y square. So, in this way I can find out the total compressive force. Now, if I see the diagram, that if rivet groups are like this, and suppose this is the plate, now this is the neutral axis where it has passed. So, this is basically h by 7 and this is basically 6 h by 7, this is the assumptions. So, from this I can say that when we have seen, when the stress distribution we used to do, we have seen that this will go like this, sorry, this will go like this. So, what will happen, that this compressive force will be total in this area and this will act at 2/3 of this distance, 2/3 of total distance. That means, the neutral, this compressive forces which is coming this one total C, this will act at a distance of 2/3 h, 2/3 of h by 7, that means 2/3 of h by 7, that means 2 h by 21, right. So, this distance will become basically 2 h by 21, in which the total compressive force will act. Now, I can make the moment at about this neutral axis. If I find out the moment, that moment, sorry, the moment can be find out as total moment due to this tensile forces plus the moment due to these compressive forces, that is summation C into 2h by 21. That means the moment about the neutral axis, if I want to find out, which is basically the external moment, means external moment will be moment resisted by the rivets in tension plus moment resisted by the rivets and section in compression. So, addition of all these will become the total external moment. So, from MT will become basically M will become MT plus 2h by 21 into MT into summation y by summation y square, if I put the value of summation C. So, this will be the M. So, from this equation I can find out the value of MT again, which is MT is M by, it is coming 1 plus 2h by 21 into summation y by summation y square, right. So, what we are seeing here, that MT is nothing but the moment due to the tensile forces which is coming into the rivet, and M is the moment which is resisting by the entire rivet group or moment which is coming from the external. So, the external moment which is applied can be used for calculation of the total moment coming to the rivet groups in tension. So, in this way I can find out. So, now again I can find out that T, say maximum T will develop where? Maximum T will be developing here, because this is the maximum distance. So, T max will be basically, we have seen MT by summation y square into y max. Y max is the maximum distance at the extreme rivet. So, in this way I can find out the T max, that maximum tensile force developing in the rivet at the extreme rivet. And what is y max? Y max can be, will be 6 by 7 into h, because this is h by 7. So, y max will be, this is the 6h by 7. So, y max will become this one 6 by 7 into h. So, now I can find out the tensile stress due to tension in rivet, that means sigma Tf calculated can be find out, which will become T max by A. That means MT into y max by A into summation y square, where A is the area of a rivet. So, from this I can find out the tensile stress at the extreme rivet. Similarly, I can find out the direct shear force. We can calculate direct shear force, that will be P by N, where N is the number of rivet and P is the force. So, tau Vf calculated can be find out by P by N into A, where A is the area of rivet. So, in this way I can find out sigma Tf calculated and tau Vf calculated. So, from this has to become less than the allowable tensile stress due to bending, and this has to become less than the allowable shear stress, that is tau Vf. This has to satisfy. This is one, and combinedly the equation which we have done, that has to also satisfy, that is tau Vf calculated by tau Vf plus sigma Tf calculated by sigma Tf less than or equal to 1.4. So, this equation also has to be satisfied. So, in this way if all these are satisfying, then the design is okay. So, in this way we can find out the rivets, the extreme rivets which are coming the maximum stresses, and whether it is more than the allowable stresses or not, that we can find out. So, what we have seen, let me summarize once again, that first we have considered that the tensile force in any rivet will be proportional to the distance from the neutral axis of the line. So, first we have considered that T varies as y, that means T will be equal to k into y, where k can be written as T by y. So, in this way I can find out the moment at that particular rivet is developing as m is equal to T into y. So, T again I can put as k into y. So, k into y, that means k y square. So, total moment similarly I can find out the summation of k y square, and if putting the value of k as T by y, we can write T by y into summation y square. And similarly, the tensile force can be find out from this formula, that mty by y square. Then total tensile force also can be find out by summing all the moments. So, total summation will be mt into summation y by summation y square. Now, as from the equilibrium equation we can say that total compressive force is equal to total tensile force. So, we can write summation T is equal to summation C is equal to this. That means the total tensile force whatever it is coming, that may be made equilibrium as means equal as summation C, and this total compressive force has to pass through the 2/3 of h by 7, because if we see the stress diagram, this is something like this and this is h by 7 and compressive force will work 2/3 of this distance. So, this is how we are getting finally 2h by 21. So, with this we can find out the moment, total moment, that means the external moment we can make equilibrium as moment resisted by rivets in tension plus moment resisted by rivets and the section in compression. So, total moment we have summed here. So, from this I can find out the mt is the total moment due to tension. So, mt which is developing in the tensile rivet can be find out from this equation, and similarly T max, the maximum tensile force developed in the extreme rivet, that also can be find out from this. So, in this way I can find out that sigma Tf cal. So, in this way I can find out sigma Tf cal and tau Vf cal, so from which I can make it. So, all this will be clear if we go through one example. Now, let us see this example, that design a connection joining the bracket angles 2 ISA 100 by 100 by 8 mm with the column flange as shown in the figure below, if power driven sub rivets are used and if power driven cold sub rivets are used. That means, we will solve this problem using first power driven hot rivets and then power driven cold rivets. So, we will see how the calculation is going to vary and how to design for the hot rivet and for cold rivet. Hot rivet means the neutral axis is at the mid of the connection at the CG, and cold rivet means neutral axis will be at h by 7, if h is the total depth then h by 7. So, in this way we have to do. So, let us see the connection. Say now say rivets are connected like this, means perpendicular to the plane of the joint. So, we are going to provide some rivet here, and this force is acting 200 kilonewton with an eccentricity of say 20 centimeter, and these are the two angle of 100 by 100 by 10. This is the column, right. So, the load is given at a 20 centimeter away from the connection. So, basically eccentricity is 20 centimeter So, the moment will develop due to this eccentricity, and we have to find out the number of rivets, its spacing, its total drawing, and whether with those spacings the joint is safe or not. So, these things we have to find out. So, let us see how to make it. So, first thing is that we are considering hot driven rivet. That means initial tension is considered. Because of hot driven rivet, initial tension will be there. So, we are considering initial tensor is there. Okay. So, for power driven shop, we know from the codal provision that sigma Tf will become 100 MPa and tau Vf will 100 MPa. These are the things which we know from the codal provision, and let us assume that we are going to use 2 rows of 20 mm diameter of hot rivet. Okay. And let us assume the pitch distance as 5 centimeter center to center. Okay. So, pitch distance we are considering 5 centimeter and 2 line of rivets has been given. So, we can find out the total number of rivets as from this formula 6 m by ampere. So, from this I can find out, right. Now, here what is m? M is the moment which is developing, that is 200 kilonewton into 20, this is eccentricity. So, this is coming 4000 kilonewton centimeter, this is one. Second thing is rivet value. Rivet value will be tau Vf, that means 100 into pi by 4 into d square. 20 mm diameter of rivet has been used. So, its gross diameter will be 21.5. So, from this I can find out Newton. This will become 36.3 into 10 cube Newton, that means 36.3 kilonewton. So, rivet value we have. Now, here m will become 2 because 2 line of rivet has been provided. So, all the values now we have. So, I can find out the value of n. 6 m, m means this is 4000 kilonewton centimeter by ampere, m is 2, p is considered as 5 centimeter and r is 36.3 kilonewton. So, from this I can find out n as 8.9. That means, we have to provide at least 9 rivets per line. Okay. So, we will consider that 9 rivets we are going to use. So, what we will do now? Now, we have to find out sigma Tf calculated. For hot rivets where the initial tension is considered, we have assumed that the neutral axis is at the h by 2 distance, that means at the middle position. This is h by 2, this is h by 2. So, this is neutral axis. So, with that we have found equation earlier that sigma Tf calculated can be find out as from this equation mpn square into a. So, if I put the values of all those, I will get 6 into 4000 by 2, m is 2, p is 5 and n is 9 and a is nothing but I can write pi by 4 into 21.5 square. A, this is A. So, after calculating these values, we will get finally this is as 8.16 kilonewton per centimeter square. So, sigma Tf calculated we are going to obtain as 8.16 kilonewton per centimeter square, right. Now, that means sigma Tf calculated will be 81.6 Newton per millimeter square. If I change the unit, which will be 81.6 Newton per millimeter square. Now, again direct shear we have to find out. Direct shear in each rivet can be find out as the force was 200 kilonewton and number of rivets is 2 into 9. So, this is coming 11.11 kilonewton. So, direct shear we can find out from here, this is kilonewton. So, shear stress due to direct shear, direct shear stress shear stress due to direct force will be this by area. That means 11.11 kilonewton means 10 to the 3 by area is pi by 4 into 21.5 square, right. So, this will become 30.6 MPa. This is nothing but tau Vf calculated. So, tau Vf calculated as obtained as 30.6 MPa. So, sigma Tf calculated as 81.6 and tau Vf calculated as 30.6. So, now, this is less than the tau Vf, which is 100 MPa allowable shear stress, and this is also less than 100 MPa allowable tensile stress due to bending. So, individually these are okay. Now, jointly we can see that this equation has to satisfy tau Vf calculated by tau Vf plus sigma Tf calculated by sigma Tf, this has to become less than 1.4. So, if we put the values, this is tau Vf is 30.6 by 100 plus 81.6 by 100, this is coming 1.122, which is less than 1.4. That means, it is completely okay. So, in this way I can make it. So, now the thing is that we have to design means we have to make all other specifications. That means, we have to draw the connections. So, how to do that? We know that connections as it is a 2 angle ISA it was told. So, its width will be ISA 100 by 100 by 10 it was. So, this is 100 and this is also 100. Then let us assume the edge distance as 40 and pitch we have already considered as 50. So, 9 rivets are there. So, 1, 2, 3, 4, 5, 6, 7, 8, 9. So, in this way I can provide 9 rivets in this place also, 3, 4, 5, 6, 7, 8, 9. Now, the pitch distance has been considered as 50 and let us assume the edge distance as say 40, whatever we can make, there is no problem. Only thing is we have to see the codal provisions and we cannot violate the codal provisions, that we have to check only. So, these are all 50. So, the total distance will become, total distance means this will become totally 8 into 50 plus 2 into 40. So, this distance will become 480 millimeter. So, the total effective depth of the joint will become 480 mm with a spacing of 50 mm. These are 20 diameter PDS, power driven sub rivet, and this is hot. That means, initial tensile is considered and this is the 100 mm width, because ISA 100 by 100 by 10 has been considered. So, in this way the design can be made. So, now in the last scene what we have seen that the value is coming 1.122. Now, if it becomes more than 1.4, then it is needless to mention that we have to redesign it. Redesign means we have to basically change the number of rivets. Change means increase the number of rivets. So, how much value is coming? depending on that we have to decide how much increasing we will do, whether 1 or 2 rivet will increase or 4, it depends on how much more than 1.4 on that basis, and of course, it based on the designer's experience also. So, in this way we can make it. Now, another example we will do, that is cold rivet, means same example with the assumptions of rivet as cold. That means initial tension is neglected. So, if initial tension is neglected, how to calculate? So, what we will do? So, similarly, we are considering the pitch distance as 5 centimeter, means 50 millimeter center to center, and 2 rows of 25 power driven sub rivets. These are the assumptions, means we have considered. So, earlier like earlier cases, these two we are considering, and edge distance, that also we are considering as a 40 mm, right. So, now we can find out the value of n, which is coming from this formula. Now, you just look that extra factor 0.8 has been multiplied with this because of the cold rivet, as we told earlier. So, now all other things are known. So, 0.8, 6, m we know, m was earlier we have calculated 4000, and m is 2, p is 5, and r is as usual 36. So, these all values are given earlier, calculated earlier. Now, we just multiplied with 0.8. So, after calculating this value, we are going to get 6.5. That means, you can use the number of rivets per line as 7, right. So, if we use total number of rivets as 7, then how we will make it? Let us see. So, 7 means 1, 2, 3, 4, 5, 6, 7. So, the total depth H will become how much? That means 6 into 50 plus 2 into 40. So, total depth will become 380 mm. So, the dimension of the connections can be decided from this, that 380 mm we are going to decide. So, now the assumption is that approximate location of neutral axis depth, approximate location of neutral axis depth, this will become how much? 1/7th of 380. That means, this is coming 54.3 mm. So, neutral axis depth is coming here, right. So, if we see the joint, this will become something like this. This is 380 and there is 2 so 2 ISA 100 by 100 by 10 has been used. So, these are 100 and these are 100, right. Now, neutral axis depth will be, so total number is, we have considered as total number of rivets as 7. So, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. So, 1/7 means 54.3, that means this is 40 and this is 50, that means 90, this is 50. So, this distance is 90. Now, neutral axis depth has been assumed as at this point, that is 54.3, right. So, that means the neutral axis is lying above one rivet, okay. Above one rivet the neutral axis is lying at 54.3. Now, from the earlier formula we can find out MT, MT is nothing but m by 1 plus 2h by 21 into summation y by summation y square. So, from this formula I can find out the MT, then T max, then sigma TF cal. So, basically the main calculation is to find out the MT. Now, find out the MT means we have to find out, we know H value we know, that is 380, M we know 4000 kilonewton centimeter, this is 380 millimeter. Now, other two parameters we have to know, that is y and y square, summation y and summation y square. What is y? Y is the distance of a particular rivet from the neutral axis. That means this is one y, this is another y, like this we have to know. So, the first rivet, this one if we consider, which is just above the neutral axis, that depth will be coming 90 minus 54.3, that is 35.7. So, this is becoming 35.7, this distance, neutral axis depth to first rivet above the neutral axis, 35.7 mm. So, summation y will become 35.7 plus, next will be 35.7 plus 50, second rivet, then it will be 35.7 plus 100, then it will be 35.7 plus 150, 35.7 plus 200. So, 1, 2, 3, 4, 5, another one 35.7 plus 250. So, this will become total y, and two lines are there. So, 2 into this. So, if we calculate this, we will get 2 into 35.7 plus 85.7 plus 135.7 plus 185.7 plus 235.7 plus 285.7. That means, this is becoming 1928.4 mm. So, summation y we could find out. Similarly, I can find out summation of y square. Summation of y square will be nothing but 2 into similar way 35.7 square plus 85.7 square plus 135.7 square plus 185.7 square plus 235.7 square plus 285.7 square. That means, y square like this we are making. So, summation y square also we can find out from this. That means, after calculating this we will get summation y square as 397,393.88. The viewers may check the calculation. This calculation may be wrong because I have done by calculator. If I press wrong button, then definitely results will come wrong. So, you please check this. Now, so MT will become now M by, M means 4000 by 1 plus 2H, H means 380 by 21 into summation y is 1928.4 and summation y square, that is 397,393.88, right. So, from this I can get 3402.5 kilonewton centimeter, right. So, in this way I can find out MT. Now, what will be the maximum tensile force at the extreme rivet? That will be MT by summation y square into y max, as per the formula we have seen. So, if I put those value 3402.5 into, okay, in next page I am just doing. So, T max will be 3402.5 into, this is kilonewton centimeter, if I make it into millimeter, I can multiply 10, then summation y square is 397,393.88 into y max means 6 by 7 of h means 380. So, from this calculation we will get the value as 27.9 kilonewton. So, I can find out sigma Tf calculated as T max by A. So, 27.9 kilonewton, that I am making Newton, by pi by 4 into this is the area of the rivet. So, from this I can find out the value as 76.82 MPa, which is less than 100 MPa. So, this is okay. And again direct shear on each rivet has to find out direct shear on each rivet, that can be find out as tau Vf cal is equal to 14.29 into 10 cube, because the shear force earlier also we have calculated this as 14.29 by pi by 4 into 21.5 square. This 14.29 can be calculated from the total load divided by 14. This is coming basically total load was 200 by 2 into 7, because total number of rivet is 14. So, from this I can find out. So, after calculating this I will get the results as tau Vf cal as 39.35 MPa, right. So, now from codal requirement I have to find out tau Vf cal by tau Vf plus sigma Tf cal by sigma Tf is equal to 39.35 by 100 plus 76.82 by 100. This is becoming 1.17, which is less than 1.4. So, this is okay. So, the design is okay, the configuration of the joint whatever we have made, that is okay. So, in this way we can check. And now, if this is not okay, means if this value is coming more than 1.17, then we have to increase the number of rivet. So, the details will be like this. So, neutral axis is going at a distance of 54.3, and in this way we are calculating h is equal to 30 and this is the dimension. So, this is the way how to calculate the rivet stresses at different places considering the rivet as cold. Okay. That means, no initial tension is assumed. Now, the same thing can be done in a accurate manner, little bit accurate manner, means here we have considered the neutral axis depth as h by 7 distance particularly, but it is not exactly h by 7, that also we can rectify, then we can calculate. So, that process just I am going to discuss again. Suppose, so this is a rivet joint we have. So, we have total number of rivets, we know that is 3, 3, 6, 7, 3, 4, 5, 6, 7, and the approximate neutral axis depth we have calculated, that is 1 by 7 into 380, that means 54.3 mm from bottom. Now, to calculate the actual neutral axis depth, which is y distance above the, means from the bottom. If neutral axis depth is y, then we can write 2 into 100 into y by 2. This is the this portion minus 2 into a into y minus 40, because of the 2 rivets which is lying here, that should be equal to 2 into rest rivet 6 into area of rivet into y1 minus y, where y1 is equal to distance of CG of rivets above neutral axis from bottom. That means, rest 6 we have neutral axis depth here. So, distance will be from bottom to here, this is okay. So, we have to calculate first up to this distance, then this. So, this will become how much? That means 50 plus 50 plus 50 by 2, this is 50, 50, this is 25, then this is again 50, from here to here 50 and then 40. So, y 1 will become 50 plus 50 plus 25 plus 50 plus 40, which is becoming 215 mm, right. So, the equation of y, to find out y, final equation will become 100 y square minus 2 into area means 363, that is pi by 4 into d square into y minus 40 is equal to 12 into 363 into y 1 means 215 minus y. Okay. So, from here I can find out the equation as 100 y square plus 3630 y minus 907500 is equal to 0. So, from this I can find out y is equal to 78.8 mm. So, what we are seeing here, that the neutral axis depth which have been assumed that at h by 7 is not correct, that is 78.8. In the earlier method we have assumed the neutral axis depth is at h by 7, but in this method we are more accurately we are doing that this is not h by 7, but this is has to be 78.8, closer to h by 7. Okay. So, if h by 7 we know, now what we will do? Now, if rivets are there, means I am not just making the exact number. So, if neutral axis is here, so this is the compression zone and this is the tensile zone. So, I have to, when I will be going to find out the stress, I have to know m by I into y. So, I have to know I, the moment of inertia of the effective area. So, moment of inertia has to find out. So, what will be that value? That will be first is for this portion. For this portion what we will do? That is 2 into 100 into this y is 78.8, then cube by 3 means BD cube by 3, basically this about this area we are going to take this minus the this 2 rivets are there. So, minus 2 into area is 363 r square. So, into 78.4 minus 40 r is basically this. So, this is 1 of because of the lower part plus the upper part. Upper part will be 2 into 363 because 363 is the area of the rivet, then a r square, 2 rivet in each line. So, 2 into area into r square means this is 90 means this is totally 90. So, 90 minus this distance. So, what we will do, that 90 minus 78.8 whole square plus 90 plus 50 minus 78.8 whole square plus 90 plus 100 means next level minus 78.8 whole square, that is 190, then 90 plus 150 minus 78.8 whole square. Like this will go on, means so up to okay plus 90 plus 200 minus 78.8 whole square plus 90 plus 250 minus 78.8 whole square. So, this will be the total moment of inertia. That means, if I make this will become something like this, I is equal to 32620.258 minus 1070.5306 plus 726 into 11.2 square plus 61.2 square plus 111.2 square plus 161.2 square plus 211.2 square plus 261.2 square. So, from this if we calculate, we will get this is around 1.44 into 10 to the power 8 millimeter to the power 4. So, in this way I can calculate. Now, it is easy to find out the sigma Tf. Sigma Tf calculated means tensile stress due to bending, right. That will be basically m by I into y. So, m is 4000 kilonewton, I am making kilonewton centimeter, that means if I make Newton millimeter, then this will be by into 10 to the 4 by 1.44 into 10 to the power 8, this is I into y means total is 380 minus 40 minus 78.8, because neutral axis depth is 78.8 from bottom, then 380 minus this minus edge distance. So, from this I can find out 72.5 MPa. So, in this way I can find out this value. Other thing is tau Vf calculated. This will become basically the total force is this 200 kilonewton by number is 2 into 7 into area is pi by 4 into d square, that means this is coming 39.3 MPa. So, in this way I can find out the total value, this tau Vf calculated by tau Vf plus sigma Tf calculated by sigma Tf is equal to 39.3 by 100 plus 72.5 by 100. Now, you see this means tau Vf has to be less than 100 and sigma Tf also has to be less than 100, first thing. Second thing is this total summation should be less than 1.4, this is coming around 1.12, which is less than 1.4. So, I can make it as okay. So, in this way I can check. So, this the second method for the cold driven rivet is more accurate than the earlier one, because here the neutral axis depth has been calculated accurately. In other process neutral axis depth has been considered as h by 7, but definitely it is not exactly at h by 7, it depends on the other issues. So, that has to be calculated properly. So, if we want to calculate properly, we have to follow the second method. So, now we can make the diagram that we need 7 number of rivets. So, 1, 2, 3, 4, 5, 6, 7, 7 number of rivets has been used and 7 number of 25 power driven shop rivets cold has been used, where the total depth will become 380 mm and the distance between rivets and edge distance has been given in this, that is 50 mm, 40 mm or so on. So, in this way you can make. So, this is all about the design of riveted joint. Riveted joint can be designed in this way. First, we have to see whether the joint is lying, means load is lying on the plane of riveted joint or perpendicular to that. On that basis we have to decide, and again if it is perpendicular to the riveted joint, then whether it is cold rivet or hot rivet. So, on that basis we have to design. Next class we will see about eccentric joint considering welded connection. How to connect through weld we will see in details.